Assalamualaikum. Mama Jani, assalamualaikum. Aku nak mikir ada nak pelit. ఇక్కడ dia.
Yeah. Good morning, my dear students. On this seventh day of physics booster classes from MS, we are going to have a topic by name SHM or oscillations, an important topic from which generally one or sometimes even two questions come in the NEET entrance examination. And as everyone knows, the knowledge of this SHM concepts we use in sound and wave motion, in physical optics we use, even in electromagnetic waves we use. So directly, maybe one or two questions come from SHM. Indirectly, its application will be there in another as many as 4 to 5 questions. So on a whole, a very important topic. Okay. Now, let us see the basic fundamentals as quickly as possible. Every one of us know what do you mean by SHM. Suppose there is a simple pendulum. Pull the bob of the simple pendulum by small angle and leave it. It will oscillate there. This is known as the to and fro oscillation. Any to and fro motion of this simple pendulum bob is called as SHM. The basic points we require here is, what do you mean by one oscillation? So starting from, let us say P there, going from P to Q and again coming back to P is known as one oscillation, and time for such an oscillation is known as a time period. Okay, frequency is the reciprocal of the time period. N is 1 by T and omega is 2 pi by T and 2 pi into N. Now, what are the most essential formulae under SHM? Okay, all the formula are compactly being written here. There, listen. Suppose this is a simple pendulum bob or any body performing SHM. Let us start counting the time when the body is at the mean position. Every one of you know that this is the mean position there, and when the bob is at the mean position, the time gets started counting. So at t0, bob is at the mean position. Now, in t seconds there, let the bob go from the mean position to any point like P, having a position x. X is the position of the particle as measured from the mean position. X is an important wording to be thoroughly understood. X is always the position of the body as measured from the mean position. That time, the body will have some velocity v, some acceleration a. When body is at mean position at t is 0, you know that x is equal to a sine omega t. What the velocity means, you have to go for differentiation. So a omega cos omega t as well as omega into under root of a square minus x square. So this is the velocity time relation and this is the velocity and position relation. Both the formula we have to be good at. What is the formula for acceleration? For any body performing SHM, acceleration is always given by minus omega square x. So minus sign says that a and x will be acting in opposite directions. What do you mean by maximum velocity? The other name of maximum velocity is nothing but velocity amplitude. Instead of using a direct wording like maximum velocity, they can use a little bit of technical wording like velocity amplitude. Velocity amplitude means maximum velocity of a body performing SHM that is given by a omega. Similarly, acceleration amplitude that corresponds to maximum acceleration. That maximum acceleration is equal to a omega square. When the body is at any position x as measured from the mean position, its potential energy is given by half m omega square x square and kinetic energy given by half m omega square into a square minus x square. Potential energy, kinetic energy, total energy is the sum of these two energies there. If you sum them up, it comes out to be half m omega square a square. Okay. The small point we have to make a note is that x is equal to a sine omega t. That formula is applicable provided the time is started counting when the body is at the mean position. At t is 0, the body need to be at the mean position. Now, just say, in some occasions there, at t is 0, body may be at the extreme position. When the body is at the extreme position, that time you started the stopwatch and that moment is 0. When the body is at the extreme position, then the time started counting. In such a case there, x is equal to a cos omega t. In such a case, x is equal to a cos omega t. The meaning of x is the same all the time. X is a portion of the body as measured from the mean portion there. Then x is equal to a cos omega t. So by now, you know that either x can be a sin omega t or a cos omega t or a general formula including this one. Okay. Now we are going to have the application of these questions here. Coming to the first bit. A combination of SHM plus kinematics. A particle performs SHM with a velocity amplitude. What do you mean by velocity amplitude? Means maximum velocity. Velocity amplitude means maximum velocity of 6.28 meter per second. I want to know what is the average speed of the particle considering one complete oscillation. Yeah, so velocity amplitude means maximum velocity that is given as 6.28. What is the formula for maximum velocity? A omega. A omega is 6.28. What is omega? Omega is 2 pi by t. So A into 2 pi by t is 6.28. You know that pi is 3.14. So 2 pi and 6.28 get cancelled. From these things, A by t comes out to be 1. First step. We have to just leave the step here and go to the next point there. Considering one complete oscillation, you want to know what is the average speed. You have to just make a note. Is he asking average speed or average velocity? Average speed is asked. Average speed is defined as total distance covered divided by total time. Average speed for one oscillation means is total distance covered. Yeah, what is the total distance covered for one oscillation? As we discussed at the beginning, one oscillation includes this to and fro motion, to and fro. During one oscillation, what is the distance covered? Distance covered is defined as actual path covered by the body. Actual path covered by the body without bothering about the directions. What is the actual path covered? All of you know that this is A, this is A. Like this, it will cover 2A. Like this, it will cover 2A. So total distance covered comes out to be 4A. And the time for one oscillation is time period T. Time for one oscillation is time period T. So it comes to be 4A by T. Out of which A by T already we have found 1. From the first step, we have found A by T 1. So 4 into 1 equal to 4 meter per second. Okay. A simple but an important model. The next bit. A body of mass 2 kilogram performs SHM starting from mean position. Very clearly said. Okay, the motion is started. That means at t0, body is at the mean position. The mass is given as 2 kg. So mass of the body is given as 2 kg there, and the motion is started from the mean position. The position x and time t are related by x is equal to 8 sine pi by 12t cos pi by 12t. When the motion starts from the mean position there, the general relation for x is equal to a sine omega t. What does it mean? We must have a single sine. We must have only one sine. But here, intentionally, both sine and cos terms are given there. Okay, x being expressed in terms of sine as well as cos. What is our duty then? Our duty should be to convert this sine and cos into a single sine term. Okay, then you have to recollect the good trigonometry. Which trigonometrical formula will make you to convert sine theta into cos theta into a single sine term? Okay, then before we go to that one there, you have to recollect the basic trigonometrical formula that sine 2 theta is equal to 2 sine theta cos theta. Okay, what is the importance of that formula here there? Using this formula, you can convert sine into cos into a single sine. Sine into cos, you can happily convert into a single sine. Okay, listen carefully. X is equal to 8 sine pi by 12t cos pi by 12t there. This is the equation given. Now, just for convenience sake, this pi by 12t, I am calling it as theta there. So this pi by 12t is again theta. Now this is of the shape x is equal to 8 sine theta cos theta. So we have got sine into cos. How do you convert sine into cos into a single time? Means sine theta cos theta can be written as sine 2 theta by 2. This can be written as, this complete term is this term, sine 2 theta by 2. This 8 by 2 get cancelled as 4. X is equal to 4 sine 2 theta. So x is 4 sine 2 theta. What is theta comes out to be? Pi t by 12. If you just do simplification there, x is equal to 4 sine, this 2 and 12 get cancelled, pi by 60. So we have successfully converted this sine into cos term into a single sine term. This is what we got it. Now, you compare this one with the standard SHM relation, x is equal to a sine omega t. You know that a comes out to be 4. If you compare xx compared, naturally is equal to compared, a is equal to 4, sine compared, tt compared, omega is pi by 6. So a is 4, omega is pi by 6. Now, what did he say? Ask in the question, find the momentum of the body when it is at the mean position. We want to know what is the momentum of the body when it is at the mean position. What is the formula for momentum? Momentum is the product of mass into velocity. Momentum at mean position means mass into velocity at mean position. Velocity at mean position is the maximum velocity. Is at mean position, you know that speed is maximum, velocity is maximum. So velocity at mean position is the maximum velocity, a omega. You know the value of a, already we calculated. We know the value of omega. Just to substitute there, you get the momentum. See that units, you write properly there. Momentum, mass into velocity, kilogram meter per second. Okay. The next bit. You please differentiate between the previous question and this bit. A particle performs SHM starting from rest. This is the key wording. Okay, that should be claritily observed. A particle performs SHM starting from rest. Okay. Particle performs SHM starting from rest means at t is equal to 0, whenever the motion starts, that time, we call that time as 0. Whenever the motion begins, that time t is 0. So, starting means starting time 0. At starting time 0, its velocity is 0. At starting time 0, it is starting from rest. What do you mean by rest? At t is 0, its velocity is 0. That's the meaning of rest. Rest means velocity is 0. When starting time is 0. Velocity is 0 means the body is at extreme position. As every one of us know that. So at the extreme point, velocity is 0. Here the velocity is maximum. So at t is 0, velocity has to be 0. Velocity has to be 0 means the body has to start from the extreme point. At t is 0, body is at the extreme point. At t is 0, body is at the extreme point means we have to go for the relation that x is equal to a cos omega t. X is equal to a cos omega t. So, if you have a proper short notes there, that point will be clear. At t is 0, the body is at the extreme position. X is equal to a cos omega t, as we discussed. Now, pay attention. So, now we have to depend on the relation x is a cos omega t. Now, in this particular question there, instead of giving a single cos there, he is giving cos square and sin square terms. Okay, we want the relation to be just a simple cos, but intentionally it is given as cos square and sin square. So x is given as 12 into, you can take 12 common, 12 into cos square pi t by 12 minus sin square pi t by 12, the 2 in centimeters there. What is the acceleration amplitude? That's what being asked. Okay, x is equal to 12. This pi t by 12, we call it as theta. This is also theta. So this is of the shape x is equal to 12 into cos square theta minus sin square theta. What is cos square theta minus sin square theta there? Simple trigonometry will tell you that cos 2 theta. We need to be thorough with the two formulae there. Sin 2 theta is 2 sin theta cos theta. Cos 2 theta is equal to cos square theta minus sin square theta. This cos square theta minus sin square theta you can write as cos 2 theta. X is equal to 12 cos 2 theta, already we know pi t by 12. So 2 and 12 get cancelled 6 times. X is equal to 12 cos pi by 60. You compare with the standard relation. X is equal to, in this particular case, as already we discussed, x is equal to a cos omega t. So comparison tells you that a is equal to 12 and omega is pi by 6. You know both the values of a and omega. But what is being asked there? What is asked means we want to know acceleration amplitude. Acceleration amplitude means maximum acceleration. How to calculate maximum acceleration? A omega square. Maximum acceleration is A omega square. So what is the amplitude? Already we know 12. Amplitude is 12. Omega square. Omega is pi by 6. Omega square means pi square by 36. Pi square by 36. So 1236 will get cancelled as many as 3 times A, 1236. You must be knowing the value of pi square. Pi is 3.14. Pi square means 3.14 whole square. That comes to be 9.9 close there. So almost we can call it as 10. Pi square is 10. So many times in different topics of physics, we approximate pi square as 10. So pi square is 10 by 3. 10 by 3 means it comes to be 3.33. Remember that all these are given in CGS system of centimeters. So the answer comes to be 3.33 centimeter per second square. Since it is given in x is given in centimeter, it is centimeter per second square. So when to use x is a sin omega t, when to use x is a cos omega t, and how to use this trigonometrical formula sin 2 theta cos 2 theta. These two questions will tell you. The next bit. One of the highly repeated question in the entrances. For a particle performing SHM, the potential energies are E1 and E2 when its positions are x1, x2. So when the position is x1, potential energy E1. When the position is x2, potential energy is E2. If the position is something different, 2x1 plus 9x2, then what is the potential energy? Okay, since decades, this is a important model. Many times the question has come in the real entrances. Okay, now the first thing is, whenever you are talking about potential energy of the body, the first step is recollect what is the formula for potential energy. Potential energy of a body performing SHM is half m omega square x square. Okay, you must be knowing that for a body performing SHM there, mass of the body will always be constant. Its a time period and angular velocity will be constant. Half is anyhow constant, mass constant, and omega is constant. For a body performing SHM, same time period will be there all the time for any oscillation. So all these are constant terms. But you know that position keeps on changing. From the mean position, closer, farther, and so on, x changes and potential energy changes. Now, these constant terms can be replaced by proportionality sign. So potential energy is directly proportional to x square. Next important step is that this small idea you should get there. Why root is being made there? Why root is being made? Okay. Then here we are talking about the position x1, position x2, some other position there. So we don't want, we want position, not position square. Here the data in was position. No, okay, not position square. Here you have got position square, but we want position. That's why they just take square root. Taking square root, E is proportional to x square. Already you understood. Taking square root of E is proportional to x. That means when A proportional to B, B is also equally proportional to A. So root E proportional to x. It means x is proportional to root E. Proportionality sign replaced by a constant term. Here proportionality sign replaced by constant term. So this particular formula will rule this small question. And you have to use that particular formula exactly thrice hereafter. So x is equal to k root E, k into root E. Now, come on, tell me, what is the data given? When the position is x1, the potential energy is E1. So that means when the position is x1, potential energy E1. When the position is x2, potential energy E2. Okay, now when the position is some new position like x3, what is x3 means? 2x1 plus 9x2. When the position is x3, like 2x1 plus 9x2, I want to know what is the energy. Okay, so when the position is x1, the corresponding energy E1. Position x2, corresponding energy E2. When the position is x3, corresponding energy E3, under root of E3. So x1 root E1, x2 root E2, x3 naturally root E3, naturally. Okay, but what is x3 given the question? x3 is given as 2x1 plus 9x2. So x3 2x1 plus 9x2 is k into root E3. Do you know x1? Yes, definitely we know thoroughly this x1 there. x1 is k root E1, x2 is k root E, x2 is equal to k root E2. So you have to write here there, x1 is k root E1, x2 is k root E2. Then, so in place of x1, k root e1, in place of x2, k root e2, and this is k root e3. You can see that k is common on both sides. The k term get cancelled. What are you getting? You are getting that root e3 is equal to, I am writing this term first, root e3 is equal to 2 root e1 plus 9 root e2. There is a chance like this. In the entrance examination, when this question has come twice, then in one exam, they have asked the root relations there, root of energy relations. Then, which of the following relations is correct means root E3 is equal to 2 root E1 plus 9 root E2. Okay, this is the answer in terms of root of energy. In one particular entrance exam, they did not give the options in this way, but they are talking in terms of E3. So when you know root E3, how to get E3 means just square it. So already you know that root E3 is 2 root E1 plus 9 root E2. If you square on either side, E3 comes out to be this complete term whole square. This complete term whole square means a plus b whole square. Simple a plus b whole square. A square plus b square plus 2ab. So here a square means you get 4e1. Here b square means 81e2. 2ab means 36 root e1 e2. So there's an answer you find here there. Okay, 4e1 plus 81 e2 plus 36 root e1 e2. So depending upon the way they give the options, either answer can be in terms of root e or just in terms of e. Both the things you have to be good at. The next bit, a simple pendulum bob performs SHM. So there's a bob performing SHM between the points B and D. So understood, this is one extreme point there. This is one extreme point. This is the other extreme point. A simple pendulum bob is performing SHM between these 2 points. It is not crossing these 2 points there. So these are the 2 extreme points, B and D. Okay. From some selected origin there, it is at a distance x. Point B is at a distance x, and this point is at a distance y. From some selected origin, this point is x, and this point is at a distance y. Now, if the velocity of the body at the midpoint of B and D, midpoint of B and D means mean position. Midpoint of B and D means exactly the mean position. So velocity of the body at the midpoint of B and D is given as V. Then you want to know what is the maximum force acting on the bob, and mass of the bob is given as m. What is the maximum force acting on the bob? Okay. So for the last time, I repeat that a simple pendulum bob is performing oscillations. Between what extreme points is it oscillating means between the points B and D. And B is at what distance from a selected origin means from a selected origin of coordinate system. This point is at x, this point is at y. Very good. And at this midpoint of B and D, here the speed is given as v. Then you want to know what is the maximum force acting on the body. Now, you have to understand first, what is the formula for force? Mass into acceleration. Mass of the bob is already given as m. Very good. Now I want to know maximum force. You know that mass is constant. Force to be maximum means acceleration is to be maximum. What is the formula for maximum acceleration there? Maximum acceleration comes out to be a omega square. Maximum speed, a omega. Maximum acceleration, a omega square. Here, mass is given. Amplitude is nowhere given. So you have to calculate amplitude. Okay, nowhere given omega. So even omega also you have to calculate. So in this question, m given, you can use. Amplitude term not given the question. Omega not given. So I have to find both a and omega and dump it here. Okay, now how to calculate the amplitude? Just say, all of you know that this is the extreme point, this is the other extreme point, and this is the mean point. Distance between the mean point and extreme point is known as amplitude. You know the meaning of amplitude. Distance between mean and extreme. Distance between this mean and extreme is another amplitude A. This is A, this is A. Okay, now you can see what is the relation between these things. X plus A plus A. X plus 2A is equal to Y. You can see that from here to here, X plus 2A is equal to Y. X plus 2A is Y. From these things, 2a is equal to y minus x. 2a is y minus x. From that, a is equal to y minus x by 2. So whatever amplitude we want, we have definitely found by simple, from this diagram, almost directly we get a. So we got a. Next step is how to calculate omega. Okay, velocity at this mean position is given as v. All of you know, velocity at the mean position is nothing but maximum velocity. Velocity at the mean position is given as v, and that velocity is the maximum velocity. What is the formula for maximum velocity? A omega. What is A we know? Already we know that A is equal to y minus x by 2. We got it. So V is equal to y minus x by 2 into omega. From that, you have to calculate omega there. Omega comes out to be 2V by y minus x. Okay, now you want to know what is the maximum force? As already being explained, maximum force is mass into maximum acceleration. Mass is given as m. A omega square you have to write. In place of A, y minus x by 2. Omega square. Omega square means 4v square by y minus x whole square. Then you have to do simplification. 4 by 2 comes out to be 2. So you get it as 2mv square by y minus x. This answer we get, please. Okay, this is the answer for the bit. The next question. See here. It is an important model. Many entrances under the name of this question. For a particle performing SHM, the velocity v and position x are related by 16 v square is 625 minus 25x square. Since it is velocity square, the unit happens to be meter square by second square. You know, velocity meter by second, v square means there is a unit. Once again, I want to know what is the acceleration amplitude. Okay, acceleration amplitude means you want maximum acceleration. Maximum acceleration is nothing but a omega square. So from this equation, you have to calculate amplitude, and you have to calculate omega, and then you have to calculate maximum acceleration. First thing is, whenever Vx terms are being talked about, what are the best relation between them? So V is equal to omega into under root of a square minus x square. So V square comes out to be omega square into a square minus x square. If you expand, V square is omega square a square minus omega square x square. That's the first step. Okay, now this is the basic equation we have to totally rely on. Now, what is given in the question there? In the question, instead of v square, he has given 16 v square. So 16 v square is given as 625 minus 25x square. I want v square. So get 16 to the denominator, get 16 to the other side. So it will come to the denominator. So v square is 625 by 16 minus 25 by 16x square. Now, if you compare these two equations, you can see that v square compared is equal to naturally compared. Then omega square a square is equal to 625 by 16 is here I have written. You can see this green comparison. This green circled one. Omega square a square is 625 by 16. And if you compare these two, omega square is 25 by 16. Okay, this red color circled, omega square is 25 by 16. Now we can say omega square is 25 by 16. From that, omega is pi by 4. You know the unit of omega, pi by 4 radian per second. The next step is take square root here, there. If you take square root, square root of omega square a square is omega a. So it comes out to be 25 by 4. Out of which omega, you know, 5 by 4. From that, a comes out to be 5 meters. You want maximum acceleration. So the maximum acceleration comes out to be a omega square. You know the value of a. You know the value of omega. So a is 5, omega square 25 by 16. In the next step, you'll be getting the answer. Is it meter per second square or centimeter per second square? So you have to see this unit carefully. Okay, all these are in SI system, SI. So naturally, here the answer comes out to be meter by second square. The next bit. A particle performs SHM with the velocity amplitude P and acceleration amplitude Q. Okay, I want to know what the amplitude of oscillation, that is a small part. And frequently asked question, for what position? For what position means for what x? He is asking potential energy is 3/4 of the kinetic energy. Okay, one routinely important question. For a particle performing SHM, the velocity amplitude is P. Intentionally, the starting data slightly given in a different way. So velocity amplitude means maximum velocity, that is A omega, that is given as P. Acceleration amplitude means A omega square, that is given as Q. Okay, so A omega is given as P. From that, omega is P by A. From this, omega you can calculate P by A. A omega square is Q. A omega means P by A now. So omega square means P by A whole square is Q. If you simplify it there, if you simplify this particular one there, this comes out to be the amplitude. If you just do simplification there, amplitude comes out to be P square by Q. Yes, amplitude comes out to be P square divided by Q. Now I want to know for what position x, potential energy is 3/4 of the kinetic energy. What is the formula for potential energy? Half m omega square x square. You have to be thorough with the formula which we discussed and which you are already thorough with. Uh, Potential energy half m omega square x square is 3/4 of kinetic energy. What is the formula for kinetic energy? Half m omega square into a square minus x square. Yeah, half m omega square term get cancelled. Some simple simplification there. You get this answer there. Okay, so instead of giving amplitude directly, you have to calculate amplitude and go for it. In the world entrances there, they are given amplitude directly as A. But here, you have to have one extra step there. Find out amplitude first and in terms of P and Q and get the answer. Okay. A particle is executing SHM along a straight line. Its velocities when its positions are x1, x2 are given by v1, v2. That means when the position is x1, velocity v1, when the position is x2, velocity is v2, you want to know what is its time period. Okay, the question says that when the position is x1, velocity v1, when the position is x2, velocity v2, from these things, our idea is to calculate time period. This is a basic question. Among different formulae in SHM, what is the correct formula to be properly recollected in time? That if you think immediately you will get it. Vx relation we want. Vx. What is the Vx relation? V is equal to omega into under root of a square minus x square. Now square it on square it on both sides. V square is omega square a square minus omega square x square. Now here you can write v1 square is omega square a square minus omega square and x1 square. Already we discussed it. For a given SHM, the amplitude and omega will remain constant. So these circle terms are constant. Circle terms are constants. So v1 square is omega square a square minus omega square x1 square. In the next case, when the position is x2, velocity is v2. Here v2 square is omega square a square minus omega square x2 square. Okay. Now, how do we get the idea that we have to do 1 minus 2? Sometimes we divide, sometimes we subtract. What is the correct logic, simple logic behind it? It means, if you see the question there, x1 given, v1 given, x2 given, v2 given, we want time period. Time period means omega. Omega is 2 pi by time period. So we have got interest and respect for x1, x2, v1, v2 and omega. But we don't want anything like amplitude A. We don't want anything like amplitude A. So we have to get rid of amplitude. How to eliminate amplitude? How to eliminate amplitude means you just subtract these two equations. If you subtract these two equations, amplitude term will get cancelled. So if you do v1 square minus v2 square there, these two terms get cancelled. And then you get omega square into x2 square minus x1 square if you subtract. From that omega square, you bring it here. Omega square comes to be this much. From that you can calculate omega. Omega is 2 pi by t. From that you can be calculating the time period. Yeah. Graphs questions are very important in any subject, in most of the chapters in physics, and definitely in SHM. Once again, an entrance question here, there. Listen, the position time graph, the position time graph of a particle performing SHM is given like this. The position time graph is given like this. You want to know what is the acceleration of the particle exactly at this time, 4/3 seconds. Okay. First of all, from in any graph, some data will be there. What do you mean by graph? Graph means data being represented by some diagram. That's the meaning of graph there. So some data will be there. Now, how to use the data? All of you know that this is x. This 1 centimeter is x maximum. If 1 centimeter is x maximum, that is the highest possible value of x. The maximum value of x itself is known as the amplitude. So from these things, the amplitude of oscillation comes out to be 1 centimeter. Amplitude of oscillation is 1. Okay, now you have to use this data properly. All of you know that this is known as one cycle. This is known as one cycle, to and fro motion. This is to, this is fro. And the time taken for one oscillation comes out to be 8 seconds there. From here to here, 8 seconds. This is to and fro motion together is one oscillation, as we discussed as the first point, please. And time period is 8 seconds. So from this data, simply you have to calculate amplitude, not 1 meter, but 1 centimeter. And time period is, you have to see, sometimes they give the value in minutes there. This is a time period in seconds. S standing for seconds. This is 8 seconds. Okay. From time period, you can calculate omega there. From time period, you can definitely calculate the omega there. So the omega here comes out to be 2 pi by t. So pi by 4 radian per second there. So it comes out to be pi by 4 radian per second. This is the value we get. Then the next point is that I want to know what is the acceleration of the particle. What is the formula for acceleration? Acceleration comes out to be A is equal to minus omega square into x. Acceleration is minus omega square into x. Okay. Now, omega comes out to be pi by 4. You have already seen that this omega is equal to pi by 4. Omega square means pi square by 16. What is x? X is equal to a sin omega t. Okay, so at t0, body is at the mean x is 0. At t0, x is 0. Then naturally x is a sin omega t. A sin, already you know omega, pi by 4 into t. Already amplitude is 1 sin pi by 4t. Okay, so acceleration is minus omega square x. Minus omega square pi square by 16. X means sin pi by 4t. He is asking acceleration at what instant of time? At t is equal to 4/3 seconds. So in place of t, you have to write 4/3. This 4 will get cancelled. So this is sin pi by 3. Pi radians means 180 degrees. Pi by 3 means 60. So it comes out to be sin 60 means √3/2. So what is the acceleration of the body here means? So minus pi square by 16 into √3/2 or √3 pi square divided by 32. And all these are given in centimeters now. So it comes out to be centimeter per second square. So this is the acceleration of the body. So much centimeter per second square. Okay. The next thing. Generally, about this particular question, which has appeared nearly 9-10 years back there, the students were wrong with one small point there. The point I want to emphasize. A simple pendulum bob of mass 600 grams. So mass of the bob is 600 grams. You are doing everything in SI system. So convert grams into kilogram, 0.6 kilogram. A simple pendulum bob of mass 600 grams is performing SHM. I want to know what is the restoring force acting on the bob when its angular position is 3 degrees. When the angular position is 3 degrees. Okay. Now listen carefully. Suppose this is a simple pendulum performing SHM there. At one stage, the angular position is theta. Then I want to know what is the restoring force. Recollecting the basics of the simple pendulum there, for the bob, weight always acts vertically down. This weight can be resolved into two components there. Okay, this weight can be resolved into components. If this is theta there. This comes out to be mg cos theta. This comes out to be mg sin theta. And this particular force that is directed towards the mean position is said to be the restoring force. Okay. The fundamental point in simple pendulum is that whenever the bob is having an angular position theta, the restoring force acting on the body is given by mg sin theta. Restoring force is mg sin theta. So the restoring force acting on the body is mg sin theta. Okay. Now we want to know what is the restoring force when the angular position is 3 degrees. The main point in the question is restoring force is mg sin theta. Okay. This theta is 3 degrees. Any angle less than 6 degrees, we call it a small angle. Any angle less than 6 degrees, we call it a small angle there. So 3 degrees is a small angle. Whenever the angle is small, you know that sin theta has to be written as theta. But the care to be taken is that sin theta should be taken as theta only when theta is being expressed in radians, never in degrees. Never in degrees. So sin theta is theta provided theta is expressed in radians. So the first and foremost task here is the angle is given as 3 degrees. Convert degrees into radians. Convert degrees into radians. 180 degrees is pi radians. 180 degrees is pi radians. 3 degrees is how many radians? So ratio and proportion. 3 by 180 into pi, pi by 60 radians. So 3 degrees is nothing but pi by 60 radian. So restoring force is mg sin theta. Mass of the bob is 0.6 kg. G is given as 10 in SI system, 10 meter per second square. Theta in radians, you have to write pi by 60. Everything you have done in SI system now. So force comes out to be in Newton. Okay. You know that 0.6 into 10 is 6 pi divided by 60. This 10 times the pi by 10. You know what is the value of pi? Pi is 22 by 7, 3.14. So 3.14 divided by 10. So here the answer comes out to be 0.314 Newton. So this will be the answer for the question, 0.314 Newton. So the main thing is when theta is small angle there, sin theta has to be expressed. Sin theta can be approximated to be theta. And theta has to be expressed in radians. There's a point to be highlighted when you are revising the things. Pay attention. Okay, see. Very, very standard question in a simple pendulum concepts. Yeah. A simple pendulum bob of mass 100 grams. This is a simple pendulum bob of mass 100 grams and is of length 40 centimeter. It is suspended to the ceiling of a lift. As you can see, this is a simple pendulum suspended to the ceiling of a lift. And the lift itself is moving up with an acceleration 0.2 meter per second square. Now I want to know, find the time taken for it to complete 10 oscillations. Okay, he's not asking time period. He's asking what is the time required for exactly 10 oscillations to be completed. And the more important other bit is, what is the maximum kinetic energy with which it oscillates if its amplitude of oscillation is 2 centimeter. Okay. The formula for time period of a simple pendulum is 2 pi root L by G, provided point of suspension is at rest. Okay, if this point of suspension is at rest, then you can apply time period is 2 pi root L by G. Here, when the lift is moving up, this point of suspension will also move up. It accelerates up. Lift is accelerating up. Point of suspension is also accelerating up. In such a case, time period of a simple pendulum is given by, in such a case, time period of a simple pendulum is 2 pi under root of L by G effective. Instead of simple G, it happens to be G effective. How to calculate effective acceleration due to gravity? Every one of you know that the regular acceleration due to gravity always act vertically down. Regular gravity act down. Now, this simple pendulum system is attached to accelerating system. Anything attached to accelerating system will experience a pseudo acceleration, but in the opposite direction. So it will have another acceleration like A, pseudo acceleration A in the opposite direction. So what is the effective acceleration under which it is oscillating under G plus A? This effective G comes out to be, in this case, G plus A. After you conclude that particular small point there, it becomes fairly direct there. So time period is 2 pi root L by G effective. In place of G effective, we have to write G plus A. Now, here you have to take care that many students directly write G as 10, 10, 10. G should be taken as 10 only when the question setter says so. If you read the question once and twice, nowhere it is mentioned that G is 10. So you have to be careful in applying G correctly as 9.8. Okay, so time period is 2 pi root L by G plus A. So G is equal to 9.8, acceleration is 0.2. So if you simplify these things, time period comes out to be 4 pi by 10 seconds. Okay, just simple after simplification, you get this. This is not the answer. He is asking what is the time for exactly 10 oscillations. Time for one oscillation comes out to be 4 pi by 10 seconds. He is asking time for 10 oscillations. For one oscillation, this much means 10 oscillations. You have to multiply with 10. So 10 into 4 pi by 10, it comes to be 4 pi seconds. Then comes the point. What is the maximum kinetic energy with which it should be oscillating? So if the amplitude of oscillation is 2 centimeter, what is the formula for maximum kinetic energy? Kinetic energy is half mv square. Maximum kinetic energy means half m into v max square. Half m into, what is the maximum velocity? A omega whole square. A omega whole square. Half into, mass of the body is 100 grams. Convert grams into kilogram. So half into 0.1. You know the amplitude of oscillation is 2 centimeter. Convert centimeters to meters, they 0.02. And already we have calculated omega here. There. How to calculate omega means, you know the time period now. You know time period is 4 pi by 10. So omega is 2 pi by t, 2 pi by time period. This 4 pi by 10 you have to write. Then you get then you will be getting this particular omega as 5 radian per second square. So you know amplitude, you know omega. Okay, already mass is given. Mass is given as 100 grams, converted into kilograms. Amplitude, he himself has given 2 centimeter, 0.02 meters. Omega value, we have just now calculated 5 there, 5. Do simplification, you get the answer in joules. Take care. They may ask the answer maybe in terms of joules, maybe suddenly in terms of erg. Okay, so you know that 1 joule is 10 to the power of 7 erg there, and you can properly get the answer there. So by being a little bit alert all the time there, okay, during the exam time, you can do well. But more importantly, you need to be much more alert and definitely hardworking. We have seen, very unfortunately, many re-NEETs and even IIT once conducted second time there. Okay, then what the past history says that in any exam that is being reconducted, exam papers will be definitely of higher standard. Exam papers will be of higher standard. Okay, then the two, after all, we are human beings there. So most of us may become lethargic. We shouldn't be. Because of getting lethargic and being papers being higher standard there, generally competition will become more and much more there. Okay, so most of you have worked so sincerely for so many years there. To have the better effect there, you need to be sensible right now. See here, this is the problem of re-NEET, not only for you, for everyone. For everyone. There is a student of mine by name Taki there. He got 700 marks in physics, 700 marks total, and 175 in physics. Okay, definitely he got disturbed the moment he heard about this re-NEET there. But by God's grace, he could set himself ready for determined, focused work hereafter. Okay, so there are plenty of students with huge marks forced to write the exam there. So this is a common situation for you and everyone there. So how best you cope up with this particular challenge, that is the main task there. Okay, then I am sure you work very well in the coming days and get the better and best rank there. So all the best, my dear students there. Good luck. I wish very good success in everything you do academically hereafter. Bye-bye. All the best.